Hey guys, Dean Chase here with another geometry lesson for you. Hope you're doing okay. It's good to be back. Let's go ahead and bow our heads for a word of prayer. Dear Heavenly Father, I want to thank you for this day you've given us, Lord. I want to thank you for all you've done. Please bless my students, help them learn, and just help us have a good day. We love you, Lord. In Jesus' name we pray, amen. Alright guys, so today we're going to be learning how to apply congruence to triangles. This is lesson 4.2, page 225. So, two geometric figures are congruent if they have exactly the same size and shape. Imagine cutting out one of the congruent figures. You could then position the cutout so that it fits perfectly onto the other figure. So right here, you have these three shapes. If you were to cut out this blue one, you could flop it onto the green one or this red one, and they would fit perfectly together. Over here though, you have these three shapes, and if you cut out this green one and tried to place it on the other two, it would not fit, so they are not congruent. So congruent means they're the same size and shape. Not congruent means they're different sizes and different shapes. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. In congruent polygons, this means that the corresponding sides and the corresponding angles are all congruent. So next slide, we'll go over that. Congruent statements. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. You can write the congruent statement in more than one way. Two possible congruent statements for the triangles at the right are triangle ABC is congruent to triangle FED. Notice that angle A is congruent to angle F, so you listed them together. Angle B is congruent to angle E, so they are listed next. And C is congruent to D, and they're listed last. So I color-coded it here to help you see it better. Triangle ABC, red, blue, green, is congruent to triangle FED, red, blue, green. Okay? They're congruent sides, or angles. Corresponding sides would be side AB is congruent to FE. And you want to make sure you write that in the same order too. A is congruent to F, so we wrote them first. B is congruent to E, so we wrote them second. Everything has to be in the same order when writing a congruent statement. Okay? Side BC is congruent to ED, and side AC is congruent to FD. Okay, I hope that made sense. Let's go ahead and put this to practice. Example 1. Write the congruent statement for the triangle shown. Identify all parts of congruent corresponding parts. Okay. So they want us to write the congruent statement. I'm going to do that last, actually. Let's go ahead and write the corresponding parts first. So if we look at this, X is congruent to N. Angle X is congruent to angle N. So let's do angles first. I'm actually going to write that. Angles. Okay. Angle X is congruent to angle N. Okay. Angle P is congruent to angle... actually, I'm going to do that in the same order too. I start with the X, so I'll start with the Z. Z is congruent to angle P. And lastly, Y is congruent to M. Angle Y is congruent to angle M. Okay, that's the corresponding angles. Now let's go ahead and look at the corresponding sides. So YX has one hash mark. MN has one hash mark. Those are congruent corresponding sides. So we'll write sides are YX is congruent to MN. Okay. XZ is congruent to NP. So XZ is congruent to NP. And then our last side would be ZY is congruent to PM. ZY is congruent to PM. And notice that all our colors are in the same order, okay? That's what you're looking for. You're looking for making sure when you're writing congruent corresponding parts that you're listing them in the same order, okay? Based on angles, really. Okay, so our congruent statement can be written in this order. X, Z, Y is congruent to N, P, M. So, triangle X, Z, Y is congruent to triangle NPM. NPM. Okay, not that bad, not super confusing, just work. It's a lot easier when you're not trying to do all the colors and stuff. I'm just trying to help it be clear and explain it well. So let's go ahead and keep going. And this is a congruent statement, by the way. Don't forget that. Example 2. In the diagram, shape ABCD is congruent to shape FGHK. Okay? So, they want us to find the value of X. AB, right here, is congruent to the first two over here, FG. Okay? So, 3x minus 6 is equal to 9, right? So, let's go ahead and write that down. 3x minus 6 is equal to 9. Okay, now to solve this, we'll add 6 to each side. These 6's cancel out. We're left with 3x equals 15. Divide by 3. Those 3's cancel out. And x equals 5. Okay, so our x equals 5, guys. Now, we want to find the value of y. And the value of y is a little trickier because if you look here, our equation is, for this angle measure, 4x plus 2y. We already solved for x, so we're actually going to plug x into this equation and just solve for y. And k is the last letter written here, is congruent to the last angle written here, which is d. So k and d are congruent angles. So let's go ahead and write 44 equals 4 times 5 plus 2y. Okay? I did 4 times 5 because in the equation it was 4x, but we know that x equals 5 right here. So let's just work this out. 44 equals 20 plus 2y. Okay? Subtract 20 from each side. These 20s cancel out, and we're left with 24. 24 equals 2y. Divide each side by 2. These 2's are going to cancel out, and y equals 12. Okay, and that's all. Once again, not bad work. It's just really, really, really important to focus on the corresponding parts. So angle A is congruent to angle F, angle B is congruent to angle G, angle C is congruent to angle H, and angle D is congruent to angle K. And with that information, you can build all your other information off of it. Okay, so let's keep going. Example 3. Maggie took the piece of fabric STUV shown in the diagram and cut it on the diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? Explain. So they want to know whether STU, triangle STU, and triangle UVS are going to be the same size and shape. Okay? And we can actually say that they are. It's going to be a lot of work, so follow along closely. But yes, they are the same size and shape. Now we have to explain why. I'm gonna just walk you through this. It's helping you gain logical reasoning here. If you know that angle V and angle VUT and angle T are congruent, we could build everything off of there. And we know that they're congruent because they are all right angles. Okay? So with that information, we can solve everything. Okay. Since these are right angles, V and U are both perpendicular to TU and SV. Okay. And also, these two angles are perpendicular to VU and ST, which means that we can say that TU and SV are parallel, and VU and ST are parallel. That's probably not the same order, but same point. And we could say that because of the lines perpendicular to a transversal theorem. Okay? By the way, it's kind of like a paragraph proof we're working through. So by doing that, we know that all these sides are parallel, which is important information, because if we take a look and we know that ST is parallel to VU, that makes this diagonal a transversal between those two parallel lines. And if it's a transversal, we know that angle 2 and 3 are congruent, and angle 1 and 4 are congruent by alternate interior angles theorem. Okay? So we're going to go ahead and say that angle 2 and angle 3 are congruent, and angle 1 and angle 4 are congruent by the alternate interior angles theorem. Okay, I'm going to go ahead and actually mark that on our nice little handy dandy picture. Angle 2 and 3, 1 and 4 are congruent. Okay, and we already stated that V and T are congruent. So now we know that all three angles in both those triangles are congruent. Okay, and that's really, really important. Now we have to prove that all the sides are congruent. And it's actually given to us that ST is congruent to UV. And it's also given to us that TU is congruent to VS. So let's go ahead and write that down. And it's already marked. These lines are congruent and these lines are congruent. So the only line we have to prove congruent is SU. And since SU is shared by both triangles and SU is congruent to itself, we could say that SU is congruent to SU by the reflective property of congruence. Okay, so now we know that all the sides and all the angles are congruent. And with that, we can say that all corresponding parts are congruent. So triangle UVS is congruent to triangle STU. Sorry. Yeah. Seems like a lot of work. Here's the deal, guys, and I'll keep saying this over and over. You need to write these examples down, because the more examples you do, the better off your logicking skills are going to be. Probably not appropriate English. Hey, I'm a math teacher. But also, when you're working on a problem, you can look back and be like, you know, this looks a lot like this proof, and you could base it off of something you've already done. So let's keep going. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Okay? And that makes sense because you can only have 180 degrees in each of these triangles. So, if these two angles are congruent to these two angles, it would make sense that the third angle also has to be congruent, because it can't just be some random number. Okay. So here they want us to find the measure of YXW, okay? This outside angle. So looking at this, we have to think of how are we going to solve for angle YXW? Well, it's kind of a really roundabout way, but if I look at this, I know that I can solve for this angle, okay? Because they give us that this angle is 35 degrees and this angle is congruent to that, so this other angle would be 35 degrees. Okay, now, last chapter we learned that every triangle is a total of, I'm just going to write it right here, 180 degrees, okay? So if this is 35 degrees and this is 35 degrees, we can solve for this angle measure with very simple math. 35 plus 35 plus x equals 180. We know that all three angles have to add up to equal 180. So that's going to be 70 plus x equals 180. Well, if we subtract 70 from each side, we know that this angle measure right here is going to be 110. Okay? So, ultimately, once again, we're trying to solve this whole outside measure. We know part of it's 35 degrees. We don't know this part. But by finding this angle measure right here, we're able to find this angle measure right here, okay? And that's going to be, this is a linear pair, okay? So they're supplementary, so 110 and this angle have to equal 180. So we know that 180 minus 110 is going to equal that measure, which is going to be 70. Okay. Another way we could have done this, I'm just going to take the time to explain this. Another way we could have solved for the 70 is we know that this exterior angle of this triangle has to be equal to the two angles added together that are opposite of it. So 35 plus 35 equals 70. Anyways, that would have been another way we could have done it. I hope that wasn't just so many words so fast. I'm sorry if it was. Now, we can solve for this angle measure because, just like this reasoning, this triangle also is 180 degrees, right? Every triangle, 180 degrees, 180, 180. Well, so far we know 40 degrees and 70 degrees, so this angle has to be whatever is left to make up the 180 degrees. So I'm going to go ahead and do a little bit of chicken scratch down here. That's going to be 40 plus 70 plus, I'm going to call it x again, has to equal 180, where x is going to be this angle. 110 plus x equals 180. Subtract 110 from each side, and we know that this is going to be 70 degrees. Okay, so this angle is 70 degrees. Sorry, I should probably put little degree symbols up here. This angle is 70 and this one's 35, and we want to know what they add up to equal. So the measure of angle YXW is equal to 70 plus 35, 105 degrees. And then we're done with that. That wasn't that bad of an example. I hope it made sense. Let's go ahead and keep going. So, a good old proof again. We're given that SV equals RV. Okay, here's the deal. Nothing is labeled on here, so the first thing I like to do when I'm solving a proof is go ahead and label the given information. So, SV is congruent to RV. Okay? TV is congruent to VW. And ST is congruent to RW. Okay, so they actually give us that all three sides are already congruent. So to prove that the triangles are congruent to each other, we know we have to prove all the sides and all the angles are congruent. So let's go ahead and write down, and we're given, one more given. Angle T is congruent to angle W. Okay, so let's go ahead and write all of our givens down just to get them out of the way. Okay, now if we're looking at these two triangles, is there any other angle you know you can prove congruent? Take a look at it. And the answer is yes, you can prove another angle congruent for sure. Because if we look here, angle SVT, SVT and RVW are vertical angles. So we could say that both of these angles are congruent, okay? So let's go ahead and say that. Those two angles are congruent by the vertical angles congruence theorem. That's not bad. Now we know two of the three angles are congruent. And if we know two of the three angles are congruent, we can actually state that angle R is congruent to angle S by the third angles congruence theorem, the one we just learned like a slide ago, 2 slides ago. Okay, so now we know all the angles are congruent and we know that all the sides are congruent, so we can state what we're trying to prove. Triangle STV is congruent to RWV. And the reason we know that is the definition of congruent triangles. The definition of congruent triangles say all corresponding parts have to be congruent. Okay. That was the last example. Just got a little piece for your notes, and then we're out of here. So, properties of congruent triangles. You have the reflexive property of congruent triangles. For any triangle, ABC, triangle ABC is congruent to triangle ABC. Reflexive property means they're congruent to itself. Symmetric property says if triangle ABC is congruent to triangle DEF, then you could flip the order and triangle DEF is still congruent to triangle ABC. And then lastly, the one that seems to be a little confusing for people is the transitive property. If triangle ABC, this triangle is congruent to triangle DEF, and DEF is congruent to JKL, then ABC would be congruent to JKL. Because here, listen here. If you were to cut ABC out, you could lay it on DEF. That's what it says, right? But it also says if you cut triangle DEF out, you could lay it on JKL. So wouldn't it make sense if you could lay ABC on this one, and you could lay this one on this one, that you could lay ABC on this triangle? It should. That's a transitive property. I'm trying to explain it in a different way because you really need to know transitive property, okay? Anyways, you guys, I hope you're doing good. Geometry should start kind of flowing a little bit better. We're going to keep doing proofs. We're going to keep learning to logic. And yeah, I hope you guys are doing good. Make sure you subscribe to the channel, hit the like button, and have a good day. See ya!